Hi students, this is Mr. Yao. In this lesson, we are going to learn more about complex number. We're going to learn operations with complex number, specifically addition and subtraction. But first, let's quickly review what we have learned in the last lesson. Prior knowledge. Simplify -3 square root of -128. So in that case, first, the number on the outside stays. This negative sign is not under the root, so we're not going to change it into an I. And then we see inside there's a negative sign and 128. That is the same as multiply with the square root of -1, and then multiply with a square root of 128. So -3 stays, square root of -1 change into an I, and then we just simplify square root of 128. And that is going to be 2 to the 7th power, so it's going to be 8 square root of 2. And then we still need to multiply the numbers together and keep the root on the back with I in the middle. So -24 I square root of 2. Again, you can choose to put this I on the end, -24 square root of 2, and then I, but you have to be very clear that this I is not under the square root. So might as well just put it in before the square root so that it's not going to cause any confusion. Then for B and C, you're trying to decide if these two numbers are rational number or irrational number. So for the first one, you can choose to multiply these two numbers together, or you can just simplify each and then see what's going to happen. So the first number is actually -4, and then times square root of 8 is a 2 square root of 2, and then multiply that. 162 is actually 81 times 2, so it's actually 9 square root of 2. And then the 2 square root of 2's together is going to be a 2. But we do need to multiply all the other numbers. That's -4 times 2, which is a -8, times 9 is a -72. And then multiply with the square root of 2 times square root of 2, which is a 2. That is -144. So in this case, that is actually a whole number, which can be expressed as a fraction. So this is a rational number. As for the other one, well, this one does seem to have a pattern, 0, 1, and then an extra 0, and then an extra 0. However, there's no part that is repeating. If you feel like it's, well, let's say you feel like it's 0, 1, 0 that is repeating, sure, the next part is 0, 1, 0, but then you actually have an extra 0 already. So it's not repeating, which means for this one, it is a rational number because it's non-repeating, non-terminating decimal. That is why it is not it is irrational number. There we go. Now let's move on. Here are a few statements. Some of them are always true, which means whatever number you give to satisfy that statement is going to be true. And some of them is sometimes true. Some of them are never true. So I'm going to ask you to pause here and go through the next few statements and then decide on if they're always true, sometimes true, or never true. Whichever you decide, try to think of some justifications. Hopefully you have taken the pause and actually think through these statements. Let's have a look. The first one, the sum of a rational number and an irrational number is irrational. So for example, rational number, let's say it's a 2, for example, and an irrational number, let's say it's a square root of 2, well, that is 2 square root of 2. So it seems that could be true, which at least is not never true. However, there is a very special number. Oh, actually, I take it back. It's a plus. It is a plus. So that means we're adding them. So a rational number and an irrational number could never cancel each other out, which is why this is never true. So example, we could just write that. 2 squared plus square root of 2 is, it just equals 2 squared plus square root of 2. And that means you can't simplify it. So it's never true. Next, the sum of two rational numbers is rational. So that basically, again, rational number is anything that could be expressed as a fraction. So it's a fraction plus a fraction. Of course, you're still going to end up with a fraction. So this is always true. So for example, like 1/2 plus 1/2, that is a 1, which is still a rational number. Next, the product. So the mistake I made in 1 was actually for this one because it's multiplication. The product of a rational number and an irrational number is irrational. So now let's see again. 2 times square root of 2, that is 2 square root of 2. So it seems to be true sometimes. But there is a very special number. So let's write this as an example. So this one does what? But at the same time, we have a very special rational number that is 0. 0 multiplied with anything is a 0. So 0 times square root of 3, for example, that's rational number multiplied with an irrational number. That's going to be a 0. So the top one is still remains irrational. But the bottom one is actually a rational number, which is why this is sometimes true. It's not always true, but it's also not never true. Okay, moving on, a few more. The sum of two irrational numbers is irrational. Well, that seems pretty legit. If you have a number that is not a fraction with a number that is not a fraction, they could stay just not a fraction. So for example, square root of 2 plus square root of 2, for example, that is 2 square root of 2. That is still irrational. However, there's also a special case, which is if you have a square root of 2, let's say plus a negative square root of 2. Numbers can always cancel each other out. In this case, you get a 0. So top one is irrational, and the bottom one is actually rational. That is why, in this case, the statement is sometimes true. It's not always true. It's not never true. The product of two rational numbers is irrational. Well, so it's a fraction multiplied with a fraction. Multiply it with a fraction. Well, fraction multiplied with a fraction is always going to remain a fraction, or you can just be like 5 times 4 is a 20, or 1/2 times a, say, 2/3, that is a 1/3. So in that case, always true. Lastly, the product of a two irrational number is irrational. Well, that seems to be legit. So for example, like square root of 2 times square root of 3, that is square root of 6. That works. But here's the thing, irrational number might be able to be simplified after some multiplication. So for example, let's say you have square root of 2 times a, let's see, square root of 18, for example. Well, that would be square root of 36, which is actually a 6. So in that case, it is sometimes true. There you go. These are the statements kind of to just for you to make sure you understand about rational number and irrational number. Moving on. Now here's something interesting. This I, which again is the imaginary unit, let me remind you, I is well, square root of -1 is I. Or in other words, I squared is -1. So let's think about it. Well, that is just I, and then I squared, according to the definition, is -1. I'm going to ask you to pause here and kind of try to figure out the rest. Maybe you'll figure them out. As you figure them out, you'll see some patterns. Okay, now let's come back and let's see. I cubed, well, that is I squared times an extra I, because cubed, there are 3 of them, right? So we have 2 of them. We just separate them into 2 of them and 1 of them. Okay, I squared is a -1 times I, that is -I. Okay, seems to kind of still going in like getting new answers. Doesn't seem to have a pattern yet. So let's continue. I to the 4th power. Well, this one you have 2 different ways. You can either write it as I squared and then squared, or you can do I to the 3rd power times an extra I. Let's say you did the first way, then I squared is a -1, and when you square it, that is a 1. Or you can do I cubed, which we just figured out is -I times I. So that is going to be -I squared, which is negative of -1, which is still a 1. So no matter what, I to the 4th power is a 1. And then let's continue I to the 5th power. Well, that would be I to the 4th power multiplied with an extra I. So it's 1 times I. That is just I. Oh, wait. You see, I to the 5th power is actually the same as I to the 1st power. Well, doesn't that mean if I continue when I get to I to the 6th power, it's going to be I to the 5th power multiplied with an I, which will be I times I, which is I squared, which is -1. There you go. Oh, sorry, not -1. Oh yeah, it is, sorry. -1, there you go. Also, I to the 6th power is the same as I squared. Well, that just tells me if I continue I to the 7th power, it is going to be -I, and I to the 8th power must also be 1. So, if you still haven't noticed, they repeat every 4 of them. So it's going to be I, then -1, then -I, and then 1. And then you come back to repeat again. Every 4 is going to repeat, so they come in groups of 4. Keep that in mind. Now let's deal with some more complicated or more higher power of the I. Example 2, 3, and 4. So I to the 55th power, well, in order to figure out what exactly is the same as, well, first I need to get rid of all of the 4s. So divided by groups of 4, that will give you 13.75, or 13 3/4. So you know at least there are 13 groups of 4s, which means they just go through the whole repetition and they just repeat each other. But after that, with this 0.75 is actually 3/4, which means I to the 5th power, 55th power is going to be the same as I to the 3rd power. Which again, I to the 3rd power, you don't have to memorize them. You can just kind of simplify it as you go. So it's I squared times an extra I, which is -1 times an extra I, and that is -I. So there you go. 0.25, if you got a 0, if you got something and a 0, that would be 1/4, right? If you got a 0.25, that would be, oh, sorry, if you got a 0, that would be just 0 power. I to the 0 power. If you got a 0.25, that is I to the 1st power. 0.5 is I to the 2nd power, and 0.75 is I to the 3rd power, because they are in groups of 4, which means each number should represent a quarter. So a quarter would be the 1st power, 2/4 would be the 2nd power, and 3/4 would be the 3rd power. Now let's continue. First, you gotta do 129 divided by 4. Get rid of all the groups of 4 of the repetitions. That is going to be 32.25. So you see it's a 0.25, which means it's going to be I to the 1st power. So I to the 129 is the same as I to the 1st power, which is just I. There you go. Now you know the pattern. You can continue with example 4, but this one you do need to be careful because there is a negative sign in the front. So in that case, you actually need to distribute to get rid of the parentheses. So it's -1 to the 74th power, and then I to the 74th power. So this part is a positive, so you are going to just get I to the 74th power. And then you can use 74 divided by 4. That is going to give you 18.5. 0.5 means it's the same as I squared. So I to the 74th power is the same as I squared, which is -1. So the whole thing would just be -1, since the -1 to the 74th power is just gone. That is example 4. Now let's move on to start doing some more about addition and subtraction. Complex number has a standard form. It's a plus bi. A is a real number, and b is also a real number. Which again means if you have just no I, if you just have a plus 0i, that would just be the whole real number group, okay, because it is just a. But we typically have a standard form, and we need to keep the I on the back, and we keep them separately. When working with complex number, we just treat I as a variable, or in other words, we treat I exactly like x. The only thing is, we do have this I squared equals -1. So whenever you see I squared, you do need to change into a -1. But before that, you are just combining like terms, just like you have x. So let's see some examples. Example 5. First, I gotta make sure to get rid of the parentheses because there is a subtraction sign. So it's a minus I, make sure you distribute the negative sign, and plus 5 minus 4i. If I change all the i's into x, I guarantee you know how to do this. Now there's no difference. So it's 8 plus 5, which is a 13, and then -I minus 4i is a -5i. And that is a plus bi, which means that my a is actually 13, and my b is -5. But you don't have to write these. I'm just showing you how to actually write the standard. So there you go. That is the answer. Next, in front of the parentheses, a plus sign, so you do not have to distribute. You can just get rid of the parentheses. Then let's get to it. -8 and a 5 is a -3. -8 is -11, and that minus I. There you go. That is example 6. Let me actually write a bit above, negative 11 minus I, because we have more examples. Example 7 and example 8. Example 7, in front of the parentheses is also plus sign, so I can just ignore all the parentheses and deal with the numbers. Negative 2 and 3 is a 1. Then negative 4i and negative 8i and negative 4i is a minus 12i. There you go. Number in the front, I on the back. That's example 7. Example 8, I do have a negative sign, so I do need to distribute that. So 3 plus 6i, then plus 8 and plus 5i. 3 and 8 together is 11. 6i and 5i together is plus 11i. There you go. That's example 8. Moving on. Example 9 and example 10. Well, this time you're not given directly with the I, you are given some roots. So we do need to rewrite them first. So let's see. 6 minus, well, this is square root of negative 1 times square root of 16. Square root of 16 is a 4, and square root of negative 1 is just an I, so you just have a 4i. Then plus, well, it's a plus sign, so we don't have to do anything, but I'm still going to keep the parentheses for now. Negative 4. Square root of negative 25 is the square root of negative 1 times square root of 25. Square root of 25 is a 5, and square root of negative 1 is an I, so it's a plus 5i. And then I can just ignore all the parentheses since in between is a plus sign. 6 minus 4 is a 2, and then negative 4i plus 5i is going to be a plus I. There you go. That's example 9. Example 10. 7 minus, well, this is a square root of negative 1 times a square root of, but square root of 5 is just square root of 5. You can't simplify it. So it's just going to be I times square root of 5. Minus, well, this is a square root of negative 1 times square root of 45. Square root of 45 is 3 square root of 5. And square root of negative 1 is just an I. So I, and then 3 square root of 5. Technically, you should actually write it as 3i then square root of 5. But since I is a variable and I kept it in the front for the previous one, because I need to combine like terms, I prefer to have just the numbers together so I'm not being confused by the I, which is totally fine. Because in my final answer, I'm going to put I in the middle between the number and the root. So this is going to be 7 minus, well, this is a 1 of square root of 5 and then I. This is a 3 of square root of 5 and I, so it's going to be a negative 4i square root of 5. And even though you're like, well, that does not look like a plus bi, we'll just try to not confuse ourselves, we kind of keep it in front of the square root. But if it's very strict, you are supposed to write it as 7 minus 4 square root of 5 and then I, and make sure I is actually outside the root. That is example 10, and that is everything for the 3.2 lesson. Thank you.